One of the most fundamental needs of all organisms is nutrition. While terrestrial foods play a significant role for human consumption, aquatic ecosystems offer something unique, rich nutritional value, and unforgettable flavors for our tables. Fish, with their high-quality protein, omega fatty acids in the unsaturated fat category, and abundance of minerals and vitamins, are an indispensable food source for those seeking a healthy lifestyle. While most aquaculture activities involve fish raised in freshwater and marine systems, bivalves, aquatic invertebrates, and planktonic organisms are also part of this production. Worldwide, about 17% of animal protein, roughly 190 million tons, comes from aquatic products. Half of this is provided by capture fisheries, while the other half is supplied through aquaculture. The global commercial value of this production has reached around $200 billion. Although the aquaculture, which make up the majority of seafood production, dates back to ancient times, in the modern era, obtaining new generations from healthy, selectively bred broodstock has become much easier and more accessible. Proper broodstock selection and balanced nutrition directly affect production quality. In fish farming, genetic performance is the most critical step towards success. The high-quality eggs obtained are incubated in hatching units to ensure the highest possible survival rates. At this stage, dead and unfertilized eggs must be removed from the system. This can be done manually using siphoning techniques or with modern automation systems that can separate viable and dead eggs while also performing counting. In this way, maximum efficiency and labor savings are achieved. These high-quality eggs can then be transported worldwide using appropriate delivery systems based on request. The high-quality eggs obtained are incubated in specialized units to achieve maximum survival rates. Feeding the fry with high-quality diets and appropriate regimes is quite essential. During the hatching phase, newly emerged fish begin by consuming their yolk sacs and then transition to a carefully managed feeding program. Inadequate feeding at this stage can lead to significant losses. Therefore, the production of phytoplankton and zooplankton as live feed is crucial for different species. High-capacity automated harvest systems are used to collect these planktonic feeds. With this nourishment, the fry become ready to transition to formulated diets. To ensure controlled production for both broodstock and hatching systems, recirculating aquaculture systems are highly effective. These systems allow water to be cleaned, reused, and monitored for pathogen control. Drum filters are particularly useful for removing suspended solids. For biological filtration, systems known as bioballs are used to maintain water quality. The cleaned water is then treated with UV before being pumped back into the tanks where the fish are held. At this stage, continuous monitoring of water quality and proper functioning of every component of the system is essential. Individuals that reach a certain size in hatchery systems are transferred to net cages where more efficient grow-out conditions are available. Transferring fish from hatcheries or land-based systems to offshore net cages is a critical step. Transport conditions can vary depending on species, water temperature, and distance. Before transfer, fish must be in good health and typically starve for a few days. The overall condition of transported fish must be carefully monitored. Cage sites should be selected away from river inflows, point source pollutants, and coastal interactions where suspended loads may increase after storms, and they must have sufficient depth. Net cages are suspended from polyethylene floaters on the water surface, secured to mooring ropes. The top of the cages should be covered with protective nets to keep predatory waterbirds away. Automated pumping systems are often used for the gentle transfer of fish into cages. In net cage aquaculture, feeding is the most frequently performed operation and therefore highly important. The frequency of feeding in cage systems depends largely on water temperature. Other factors shaping the feeding regime include the fish species and their live weights. Today, feeding can be carried out using labor-intensive pneumatic methods, but more efficient barge-based automatic feeding systems are also widely used. These systems, integrated with channels for each cage, deliver feed quickly and with minimal stress to the fish. As a result, thousands of fish can be fed efficiently in a short period of time. In offshore aquaculture systems, the entire cage infrastructure, including anchors, chains, ropes, shackles, and buoys that are not visible from the surface, must be continuously monitored to prevent potential problems. For this purpose, divers, an important risk group in terms of occupational safety, are needed. In recent years, drone technology developed for underwater inspections has been increasingly used to monitor cage systems and auxiliary marine equipment. These systems eliminate safety risks while providing detailed views of underwater structures, allowing observation of fish behavior and real-time recording. Before transferring fish to cage systems, as well as during their growth period in cages, counting and size grading are crucial for managing feeding regimes, planning harvest, and meeting market demand. Automation systems developed for this purpose operate with high efficiency. Monitoring water quality parameters is one of the key elements of an efficient aquaculture process. Factors such as feeding regimes, stocking density, and fish welfare depend directly on water quality. While manual measurement tools are still used, today cage systems are increasingly equipped with integrated, remotely connected systems that provide real-time data. These technologies enable continuous monitoring of water quality parameters, generate statistical data sets with ease, and make annual records a key to secure production for the future. Fish health is another crucial aspect that producers must closely monitor in aquaculture systems. The selection of healthy individuals, the implementation of modern farming practices, vaccination, hygiene, and quality feeding are indispensable components of fish health management. Maintaining fish health requires routine laboratory checks, accurate diagnosis, and appropriate chemical treatments. For this purpose, various automation systems are used to monitor blood parameters. Among protective measures, vaccination holds a leading role. In individuals with a developed immune system, vaccines, particularly against bacterial pathogens, yield highly successful results. In fish, vaccination is performed via immersion for smaller individuals, while injection is used for larger ones. These procedures add stress to fish that are already under handling stress, which is why anesthesia is applied prior to vaccination to minimize it. This stage requires fast and precise management, supported by experienced personnel. To improve efficiency, automated vaccination systems have been developed, allowing fish to be vaccinated in the shortest possible time and with minimal stress. Vaccinated fish can then be transferred to different aquaculture systems after an immunity period of about 15 days, ensuring they are protected from diseases until harvest. The entire aquaculture production and farming process should be determined according to customer and market needs. This process ends with harvesting. Bivalves that reach the harvest stage can be easily harvested with automatic scrapers. In fish harvesting, the meat quality depends on carrying out a healthy harvest process. Fish are starved for about 3 days before the harvest application begins. To ensure long durability of processed fish and to have high attractiveness in the marketing stage, it is very important that the harvest process is done quickly and with consideration for fish welfare. In the harvest stage, it is very important to run the process quickly to avoid harming the harvested fish and to use labor economically. For this purpose, different harvesting machines and systems have been produced. After the fish are gathered inside the cage, fish harvesting can be carried out safely, efficiently, and in short times with motor pumps and transfer systems. It is undeniable that future technological developments will take aquaculture to even greater heights.